This unit that we're on here is Unit 6, which is Linear Relations. Really, really important unit that we're going to use. We're going to use this material from now until all the grades that you'll be taking in mathematics in high school, so really important topics. And we'll refer to this all the time. This is the 1 year that you kind of learn it, and then we use this all the time. So we want to really remember this and pay attention to all of this stuff. I'm just going to fix the camera a bit there. First section we're doing here is 6.1, which is called the equation of a line. We'll use these words all the time, so equation of a line. We're doing a line, and when we say line, we mean a straight line. So we mean like this, not a curve. If we want a curve, we'll say curve, but if we want a line, so anytime we say line, we automatically mean a straight line. Okay, so we don't say straight line, but we say line. So line in mathematics means it has to be a straight line, like that can be done with a ruler, not a curve. Okay, so that's an automatic assumption. When I say it's a line, we don't mean a curved line. There is something called a point slope form, which is this kind of thing here. So if you have outside help or looking at older videos, some of them use this format of the equation of a line. I don't tend to use this one. So we'll not be using this format. I'm going to be using the y equals mx plus b one. So I like this one, and that I'll just kind of rely on this. They're the same they're the same thing, just slightly different, shifted over a little bit. I like this form. Okay, so again, if someone's showing you this one, that's fine. We're going to concentrate on just this one type, and this one works for everything as well. So this is called the slope y-intercept form. The reason why it's called the slope y-intercept form is because this is the slope, the m is the slope, equals slope, and that's a lowercase m, so this is lowercase. Okay, please don't do uppercase, so lowercase m. Y-intercept, so it's slope, y-intercept form, because this one here, that one there, that b is actually the y-intercept. Sorry, my words got cut off there in the corner. Okay, y-intercept. So b is the y-intercept, and that's why it's called slope y-intercept form, because you can read the slope and the y-intercept very quickly as soon as you look at it. What we need excuse me, is that the y equals is on one side. So you see this exact format. It's y equals, and then I want the number in front of the x plus the extra number after it. And this is what is called y-intercept. It's also called a vertical intercept. So if you're like, what's the y-intercept? This is the y. So look here. Y is this line. That's the y. This is called the y-intercept. Where do you hit the y-axis? It's also called vertical. Why is that? Because this is the vertical line. So it's a vertical intercept. If this line was, say, not y and x, maybe it was height, and we were doing an experiment with height versus time, I would call it the h-intercept. Maybe I was calling that h. Or maybe it's cost, and I had c here, so it'd be the c-intercept. So do you see where the words are coming from? So y-intercept, it could be called vertical intercept, or whatever the wording of it is. So there we go. So in this case, my y-intercept would be this number right here. Right, so that number there, that would tell me that my b equals 2. So that's my y-intercept of 2. So that in this form, over here, what would my slope be? So my slope of the line is going to be from any point. You can start at any point, doesn't have to be the y-intercept, and you're going to count the rise and the run. So from this point, I'll just start here. You can start at any. It's going to be the same if it's a linear, a line, a straight line, the slope will be the same for the whole time, right? It doesn't change. So I'm going to count the squares. What do I mean by count the squares? It means I want you to make this into a right angled triangle. So think of this, I'm just highlighting. So you're going to draw this down until you hit a corner and then go straight across. So I don't want it angled. I want straight across at a 90-degree angle, so a little 90-degree corner there. And so count the squares with me. So this one here is 1, 2, 3, and 3 squares, right? This is 1, 2, 3, 4 squares across. So this is going to be a rise And then very, very, very important, watch, of negative 3. Because from this point, I dropped 3, negative. Okay, and you're going to lose a mark every time you drop a negative from now on. It's a full mark, nothing less, because it's super important. What that negative is saying is that, look at the line. It's heading down to the right, and we learned this in the other unit. Down to the right means it's a negative line. I know right away, as soon as I look at this diagram of this line, it's negative, so we'll be heading down to the right. So that's a negative. Negative 3. My run, and I want you to write it, my run, so this is my rise, is negative 3, and my run is 4. How do I know that's positive? Because it's to the right. I'm heading to the right. Right is positive, and up is positive. So this one here. And so you might say, well, what if I started another point? Well, you'd go backwards. So if I started here and I went backwards, I would go left 4, up 3. That would give me a negative 4 and a positive 3. But look what happens when you write your slope. So my m equals, and this is, we learned this in last unit, my rise over run. Do you have to write this? Yes, you have to write this. You have to tell me what you're thinking. Did you label it? Yes, you have to label it. I need this labeled and this labeled. I'll look over here and go, okay, you told me what your rise and run is. You labeled it on your diagram. You wrote down your formula, which must be written with the m and the rise and the run. Lowercase m equals this. This is the format you're going to use from now until you finish high school mathematics. And in grade 12, you still, in grade 10, all the other grades, you don't want to still lose the same marks. Because if you don't write this down, don't show your work here, you're going to lose marks every time. So then you're going to do, rise is negative 3 over 4. So you might say, well, wait, I started at this point, so I'll show you it works either way, and I went backwards. So then that would be a run. So if you had this, and you started here, and you did this, and went backwards, so I went backwards, that would be a run of negative 4, and my rise would be 3, so when you count back up. But when you do your rise over run, you're going to get a rise of 3 and a run of negative 4, and is that the same? It is once you move the negative up. So way back before when we did fractions, in that fraction unit, we always told you to move the negative up. So then you'd move it up to the top, and look, you'd get the same answer. So it doesn't matter which 2 points you use on the graph. And then you might say, wait, I used this point and this point. But when you look at the full triangle, so I'm just going to highlight that. So if you use the bigger triangle and went like this and up, this is 8 squares, right? So doing it this way is fine. And what if you said, okay, but I used the bigger triangle. Let's look at this. My m would be still rise over run. On your big triangle, you would show me, oops, sorry, I'm just pretending that I had this one and I did this, so I used this point down here and this point up here. And then when you draw that, you're going to see that my run is 8 and my rise is negative 6. So if you count this, 1, 2, 3, 4, 5, 6 squares here, and my run is 8. 1, 2, 3, 4, 5, 6, 7, 8. What is, when you do your rise over your run, what's negative 6 over 8 reduced to? So you always reduce your fraction. ARF stands for always reduced fraction. So that would be negative 3 over 4. And look, you'll get the same answer. So for any line, you're going to get the same answer any way you do it. So whether you use this point and this point, those 2 points, these 2 points, you're going to still get a rise and run of negative 3 over 4 if you're doing it mathematically correct. Okay, so hopefully that helps. Now, back to the equation. My equation is this. So my equation is always going to be written in the form y equals mx plus b. And what we want to fill in on my equation is always the m and the b. Okay, so you don't have to write this. This is my brain thinking it. So I always want to rewrite it. And I want to, so my answer for this, if I was to write the equation of this, I'm going to show the work, show it's a negative, get it over here, and my equation is y equals m is negative 3 over 4, x goes in the middle. Okay, I'm going to highlight this. I want the x in the middle of this line, not at the bottom, not too far at the top, in the middle. The fraction goes in front. And then your b is plus 2. So this is called the equation of the line. Y equals mx plus b. So this tells me everything I need to know about the line. It tells me that my y-intercept is 2, and that the rise and the run is -3/4, so I can draw the whole line. It's beautiful. So that's what an equation of a line is. An equation of a line gives us all the information so that I can draw this line with the information I've been given. So everyone will draw the same line. That's what this is for. Okay. There's another form of the equation of a line. It's called standard form. We're not going to learn standard form this year, but at the end of the chapter, we're going to learn how to do the algebra of it. So I'm not going to ask you to memorize what standard form is. That's for next year, but I need you to be able to do the algebra, be able to move things back and forth. So just like what we did in the algebra section, I think it was chapter 4, where we were able to manipulate. So I want you to practice the manipulation of it, and we'll worry about this word later on. So you don't have to memorize the word standard form, but I'll say, can you please take this and then move it around algebraically? So just doing a bit of algebra with it to get it into this form, but not like learning the standard form idea until later on. We'll do that probably next year, but I want you to be able to do the algebra of it. So back to chapter 4 and doing just a little bit of algebra manipulation. Okay, so you don't have to memorize that word though. Here, my next example says, so now that we know what an equation tells us how to graph the line, tells you y-intercept, and tells you the slope. It's a beautiful thing. This form is not negotiable. It's y equals mx plus b. The order matters. So the order matters. So order matters. You can't say, well, I have all the same stuff, it's just in the wrong order. No, I want it in this order, so the order does matter. So now when I give you something like this, you can see it's y equals mx plus b. So you can read from here, this m equals 4, so that's the slope. What is the slope? And what is the y-intercept of the following lines? So we have the slope, which is the 4, and the y-intercept, which is this number here. You grab that whole number, including the negative. So that means it starts at -6. Then this next one here, we've got y equals 3. This one's a tricky one, so this one's different because y equals 3, but there's nothing else there. So what I need you to do is be able to picture it. So if I give you the graph and I say this is y, and I say this is x here, I'm telling you that y is 3. So y is 3, which is here, right? So 3. And y is 3 for the whole line. So no matter where you go on this line, y will be 3 for the entire line. So that means it's actually going across. So y equals 3 means it's going across for the whole line. That means it's only ever going to be 3, so always. So what type of slope does y equal 3 have? We learned this in the other unit 5. So that tells me the slope is 0, and the y-intercept will be 3, because it goes through 3 and it keeps going. That's important. We're going to star this, because these two are very important. They're called special cases, and you're going to use these again from now until forever. So next year, the next years, I'm going to say, give me the horizontal line, give me the vertical line. So this is a horizontal line. This one's going to be the opposite here. So it's going to be, I'm going to draw it over here. So it's telling me the x is 2 forever. So x is 2 there, and only 2, which means x is 2, 2, 2, 2, 2, 2, 2. So that means it's going to be a vertical line through 2. So x is 2 forever, so just right through 2. So then that tells me my slope is going to be undefined. We learned this in chapter 5. And my intercept, my y-intercept, it never ever turns and hits it, so none. You have to use these words, none, not 0. Okay? So you're going to use 0, undefined, none, use these words. You can't say b equals 0. B equals 0 means it goes through 0. You have to use the word none. So use the word none and undefined. So that's what my little bubble of knowledge here, this is your brain going, oh, I know there's like a thought bubble here, right? So horizontal lines have a slope of, so anytime you think of a horizontal line, horizontal lines do this. They have a slope of 0, and the equation will always look like y equals a number, right? So when I think about this, it's going to be on the axis, it'll be y equals some number like this. So y equals a number. Then a vertical line, so a vertical line does this, and they have a slope that's called undefined. And they will always, when you think about that, I go, okay, that means my x has a number, and it does this. So my x equals some number all the time. Okay, my last one here, last two here. If I give you a situational one, so if we say cost and we say hours, same idea. My y-intercept, so my b is 30. I want you to label that. I want you to tell me the rise and the run, so you can use any of the points that go through a corner. So I find the corner ones. So if I'm going to do this one, I do a right angle. I'm going to grab this guy here at a right angle, and I'm going to say my rise. Now this is tricky. I'm going to put a star on this as well. Look at units. So look at the units. Oh, scale. We want to look at the scale. So you want to look at the scale. Okay, so you want to look at the scale. And this scale here is that each one of these is 10. So my rise is actually 10. Okay, and my run is 1, 2, 3 squares, but every square is 1. Yeah, so my run is 3. So then my M is rise over run, which is going to be 10 over 3, which is in money approximately 3.33. And I know already that my B is 30. So then when we write my equation, y equals m, so 333 x plus 30. And yes, you could have left that as a fraction. I do love fractions. Okay, so or. There you go. I'll do another video for those last two on the bottom.